Okay, we should start what we're going to do today. I'll start by sharing my whiteboard. So what we're looking at in this chapter is referred to as simple interest. The equations here should be fairly easy compared to some of the equations that you've had to deal with in all the work we've done with compound interest. So let's just go over, first off, what they're doing here. They're starting out with this concept that the interest amount equals the principal times the rate times the time. So P here is the principal. Which is always going to be a dollar figure. R is the interest rate, which is always going to be the annual rate. They're always going to give us the annual interest rate. And T is the time period. And for some reason, when we're doing simple interest, time period is either days, months, or years. For some weird reason, they don't give us semi-annuals and quarters when we're dealing with simple interest. And the rate is always going to be given to us in annual. And so if they give us days, we're going to have to translate this. We're going to have to go divided by 365 to make this into an annual time period. If they give us months, it'll be divided by 12. And of course, if they give us years, it's divided by 1, which is not really something we're ever going to bother doing.
Pwede makigamit ng BPI pa. Pag may pagka-transfer lang ako.
Ano kanino ito transfer?
Hindi. Papunta sa iyo yung pera.
Ah, sige. Kinentin mo sa dati, di ba?
Ha? Hindi pa ako nangyayari ng BPI sir.
So let's take a look at what they've done here. Compute the amount of interest, that's this big I, earned by this amount of money at 3.5% in 173 days. So I is going to be equal to 1290 times 3.5%. So we could translate this into 0.035 because it's already annual. Per annum is annual. Times 173 over 365. So if you figured that out, put that answer in the chat box and we'll see if we agree on it. The next one is I equals 1290 times 3.5% or 0.035. But it's 5 months, but we have to translate that into 5/12 of a year. And the last one is I equals 1290 times 0.035 times 2 years. And we don't have to translate it into anything. So now we need a calculator. And what do we get here? I'll start with 173 divided by 365 times 3.5% times 1290. And I got $21.40, which is what we saw in the chat box once we round it to 2 decimals. And then 5 divided by 12 times 3.5% times 1290, $18.81. And 2 times 3.5% times 1290 and $90.30. Okay. So always remember that in these questions, the rate is always going to be given to you in the annual, even though they don't always say per annum. Assume it's annual. And the time period can be days, months, or years, but always has to be translated into part of a year. So, any questions on that before they do everything they can to ruin our day here?
Excuse
See
me,
what else
sir.
they can do. I hear a question.
Sir, could you explain it again? Because I was late in the class.
Okay, yes. The equation we're using to begin with here is I, which is the interest amount, is equal to the principal times the rate times the time. The principal is always a dollar figure. The rate is always given to us in the annual per year. Here it says per annum. It won't always say per annum, but always assume it's per year. The time period always has to be translated or converted into part of a year. Here they gave us 173 days, but we have to go 173 over 365 to get a decimal part of a year, and we can't round it off. It's just part of our calculation. Whereas months, they gave us 5 months, but we've got to go 5/12 of a year. If they give us years, of course, it's divided by 1, which we're not going to bother doing. And so whenever you're calculating this, the amount of interest, that's how you're going to have to do it. Does that help?
Yes, sir. Thank you, sir.
Okay, we'll use this equation and forms of it quite a bit. So let's look at the next thing they do to us here. They've said what principal will earn 67.14 interest at 6.25% in 82 days. So go back to that original equation we had. I equals P RT. And what they're expecting us to do now is turn this inside out. If we are solving for the principal, it'll be I over RT. If we're solving for the rate, it'll be I over PR. And if we're solving for the time, it'll be I over oh no, I did, this one's wrong. Can't have an R here. I over PT, sorry. And here it's I over PR. So they're going to get us to turn this thing inside out. But if we do that, when we get this answer, it's going to give us a decimal value. We're always going to have to go times 100 to turn it into a percentage, because they're going to want the rate in terms of a percentage. The time is a bit trickier because we're going to get some kind of a decimal value here. And depending on whether we're dealing with days, months, or years, if this question is dealing with days, we'd have to take this decimal answer and go times 365, because the decimal is part of a year, but we want to know how many days it is. If it's months, we're going to have to go times 12. And of course, if it's years, it's times 1, which we're not going to bother doing, but that's the concept. So here they're asking us about the principal. So we can see we're going to be solving for the principal. So the principal equals the interest amount that they've given us, 67.14, over the rate, which is, we were going to translate it into a decimal, 0.0625, and 82 days still has to be over 365. So when you get this in your calculator, I'm going to start with the 82. 82 divided by 365, then times the 6.25%. And then in order to flip the numerator into the denominator, I'm going to hit 1 over x and go times 67.14. And I will be getting 4781.68. So any thoughts, concerns, cries of agony, moans of despair at that point? Okay, let's take a look at the next one. Please explain days, 365 months. Okay. When we do time, let's see, that's going to be question number 4. And then you'll see how this works. So, Balwinder, hold that question until we look at question number 4 when we actually have to do this, okay? So now they're saying what interest rate is paid if the interest on a loan of 2,500 for 6 months is 81.25. So now we're solving for the rate. So it's going to be the interest amount over the principal times the time. And they've told us the interest amount, 81.25. And they've told us the principal, 2,500. And the time was 6 months. So 6/12 of a year. So again, I'm going to start with the 6/12. 6 divided by 12 times 2,500. Then I need to flip the numerator into the denominator. So 1/x. And then times 81.25. And my calculator is set to 2 decimals, but let's set it to more decimals than that. Let's go second, format 9, enter, clear, recall. So I'm getting 0.065. But whenever we're getting the rate, we're always going to have to go times 100 to turn it into a percentage. So times 100 is going to give me 6.5%. So I noticed some people did get that answer and put it in the chat box. Is anybody not able to get that answer? Okay, let's look at question number 4, where we deal with the time situation. So it says, how long will it take 8,500 to grow to $8,818.75 at 5% per annum? And they want to know in days, in months, and in years. So we're trying to calculate the time, and it's going to be equal to the interest amount divided by the principal times the rate. So the principal here is, or no, the interest amount here is, we have to figure it out ourselves, I guess. 81, oh, that didn't work. 8818.75 minus 8500. And the principal was 8500, and the interest is 0.05. So let's do this calculation at the top first. 8818.75 minus 8500. This is 318.75. So now we can solve this. I'll start at the bottom again. 5% times 8500. Then I want to flip that into the numerator or the denominator, 1/x times 318.75. And what I'm getting is 0.75. But if I need to translate that into days, I've got to go times 365, because this is 0.75 of a year. So I'm getting 273 3 days, 0.75. So I'd say 274 days. And if I wanted to translate it into months, I'd have to go times 12. And I get 9 months. So this was days. So the 9 months makes sense. 3/4 of a year is going to be 9 months. If I need to translate it into years, I don't have to do anything to it. Times 1 equals 0.75 of a year. So whenever you do this calculation, you get a number, but sometimes that number makes absolutely no sense whatsoever because it's a decimal part of a year. And we don't usually think of parts of a year in terms of decimals. We think of parts of a year in terms of days and months. So let's see what else they can do to us. With this concept. They take a perfectly reasonable, simple concept, and then they go out of their way to make it as hard as possible eventually. So now they want the maturity value. So let's go through what they've done to the equation. We started out with this concept. Principal equals, oh no, we didn't. Try that again. Interest amount equals principal, rate, and time. But this is just giving us the interest amount. What they want now is the maturity value. So what they're wanting us to calculate is the principal plus the interest amount, which will give us what they call the sum. They use the letter S representing the sum of principal plus interest. And what they do is they substitute this PRT into here. So they get S equals principal plus principal times rate times time. And then they factor out the letter P. So S equals the principal outside of 1 plus RT. And this will give us, this S is our maturity value or our future value. And this is how they're going to expect us to calculate it. So let's take a look here. A principal of 6,000 at 3.75 for 300 days. So S equals the principal 6,000 1 plus R, which is 0.0375 times 300 over 365. And you have to make sure that you're following BEDMAS when you do this calculation. Start with the 300 divided by 365, then times the 3.75%, and then do the plus 1. If you do 1 plus 3.75% first, bad things will happen and life will go downhill from that point on. So then times 6,000, and I'm getting 6,184 0.93. So try the same thing with months. S equals 6,000. 1 plus 0.0375 times, but as it's months, we're going to have to go 10 over 12. And again, we've got to start with the 10 over 12. 10 divided by 12 times 3.75%. And then do the plus 1, and then times 6,000. And I am getting 6,187.50. And then we got 3 years. So S equals 6,000, 1 plus 0.0375, but 3 years is just 3. So let's see what we've done here. So 3 times 3.75% plus 1 times 6,000, and I'm getting 6,675. So that's how they're going to get you to calculate for the future value or the maturity value. They're going to refer to it as S, which is the sum of the principal plus interest. And the next thing they're going to do is they're going to get you to manipulate this so you can solve for the principal. Let's take a look at number 6 here. So they're saying a maturity value will be this much. So they're giving us the maturity value. So what they've done here is they've taken this equation that we just generated. Let's put it here. S equals principal 1 plus RT. And they've just divided through by everything in the bracket. So they get principal equals S over 1 plus RT. And so we can use this now because we know the maturity value, that's S. So principal equals 4400 over 1 plus the rate of 0.0325. And I know it sounds ridiculous, but the easiest thing to do is to miss out this 0 times 243 over 365. Someone has asked, can we do these questions on the financial calculator? And unfortunately, you do not have a program. They don't have a function for calculating simple interest. They've decided simple interest is simple and that we should do it by hand. So I don't know if you can sort of make the compound interest functions work for simple interest. But I've never figured out a way of doing it. So here we're going to again start with the 243. So 243 divided by 365 and then times 3.25%, and then do the +1. And then I've got to flip this from the denominator into the numerator. So 1 over x times 4400. And I'm getting 4306.81. And then we're going to do the same thing, but now we're dealing with months. So principal equals 4400 over 1 plus 0.0325 times 8/12 of a year. So 8 divided by 12 times 3.25% equals, then +1, then 1 over x times 4400, and I'm getting 4306.69. And then we're going to do the same for 1 year. So principal equals 4400 over 1 plus 0.0325 times 1, basically. So I don't really need to do 1 times. So I've got 3.25% plus 1, still 1 over x times 4400. And I got 4261.50. So these are the two equations. They're going to give us all sorts of situations where we're using these two equations, where we're either moving money forward or moving money backward. And the whole sort of basis to this chapter is that when you move money forward, it gains interest. And when you move money backwards, it loses interest. And so now they're just going to get us to work with different situations where they try to make this more and more complicated. So what principal will earn 55.99 interest at 9.75% per annum from February 4th, 2021 to July 6th? So what we've got to do is figure out how to find what they call the days between dates. We can do this using a table, which is functional, but not the easiest way to do it. We can do it using the BA2 plus, or we can do it using Excel. So first off, let's use the BA2 plus. So let's make a note of the dates. We're going from February 4th, 2021 to July 6th, 2021. And I'll go over to the calculator. So can you see the calculator?
Yes, sir.
Okay, let's clear this. So when we're trying to find days between dates on the calculator, the second function of the number 1 button down here is the date function. So what I'm going to do is I'm going to go second and date. And it says DT1, which is date 1. And it has in there the last date that I must have used for calculating. And the format here always has to be months, days, and years. So for February, it's going to be the second month. And then I've got to put a period. So 2 period. And then for the 4th, I've got to put 04. So 04. And for the year, I can only put the last 2 digits of the year, 21. And then, so this is February 4th, 2021. And then I've got to go enter and hit the down arrow. So now I'm looking at date 2. So it's July, which is the 7th month. And I've got to put 0621. So 7 and then a dot. And then for the day 06 and for the year 21. And I go enter and it can show me 7062021. So I did enter and I go down and now it says DBD, but it hasn't done anything yet. I've got to go compute. So what it's telling me is between those 2 dates is 152 days. On one of the formula sheets, you have a little example of how to do days between dates on the calculator, but that's how we would do it. Let's also go over and see how to do it on Excel. So we'll
Sir,
stop.
can you please
Oh, what was
can
that
you
again?
can you please repeat it?
Yes, let's clear that all. Go to the second function, right? Second. And it's the second function of the date of the number 1. Says date above it. And the first thing you'll see is DT1. And we're looking for February. So that's the second month. The format here always has to be month, dot, day, year. So month, I'll put in 2, dot. Then it's the 4th day, so 04. And it's 2021, but I can only put in the 21. So when I hit enter, I can see it a little more clearly. It's the second month, the 4th day, and 2021. So that's DT1. Hit the down arrow, and it lets you put in DT2. The format is the same. The 7th month, so 7 then period. And then it's the 6th day, so 06. And then the year is 2021, but I can only put in the 21. And when I hit enter, it's a little more legible. 7th month, 6th day of 2021. So then hit the down arrow and you're looking at days between dates. And it has the last calculation in here, which for us, we just did it. It was 151. But go compute and it'll do the calculation again. Let's look at it on using Excel. So now I'm hoping, oops. I'm hoping you can see an Excel spreadsheet. Am I correct?
Yes.
Okay, I'll make this a little larger so we can see it. So on Excel, it is actually incredibly easy. I'm going to type in I better spell it. February 4, comma 2021. So we've got that in this cell, and then July 6, comma space 2021. So we got that into this one, and then I go equals this one minus this one, and there's my 152. So as you have access to both the BA2 Plus and Excel, there are some things that are easier to do on Excel and some that are easier to do on the BA2 Plus. But when you're looking for days between dates, it's way easier on Excel than on the BA2 Plus. Just type in the date in the correct format, right? That is the month, the day, comma, space, year, and then just go this one minus this one, and it'll give you the answer. So now that we're fairly sure we're dealing with days between dates, we're dealing with 152 days. Let's go back to the whiteboard and we can solve this question. So the principal will earn this much interest. So we're looking for the principal, and that's going to be I over RT. So the interest amount was $55.99. The rate was 0.0975, and the time we've determined was 152 over 365. So I'm going to start with the 152. 152 divided by 365 times 9.75%, and then hit the 1 over x times 55.99. And I don't know if anybody else did this calculation. I got 1378.97. Did anybody get the same answer? 1397.36, 1378.97. So I got a couple of different answers there. A couple people agree with mine, so I'm going to hope mine is right, unless someone can demonstrate to me that it's totally wrong. So let's find the questions again. I lost them. So compute the amount of interest on $835 at 7.5% per annum from October 8th 2023 to August 4th. So I need a few people to figure out how many days this is. We're looking for the amount of interest equals the principal times the rate times the time. The principal is 835 times the rate 0.75. Oh, that's exactly what I told you not to do. Don't forget that 0 times a certain number of days over 365. So whether you're using the BA2 Plus or Excel, what kind of a data you're going to come up with? If you're using the BA2 Plus, we'd be plugging in October, which is what, the 10th month? So 10.0823, and August is the 8th month, .0424. Second date 10.0823, enter down 8.0424, enter down, compute. And I also am getting 301 days on the BA2 Plus. So I don't know whether you did it on the BA2 Plus or you did it on Excel. Harpreet, that's a strange answer, unless it's the final answer to the question. That would make more sense. So 301 divided by 365 times 7.5% times 835. And then I'm getting 51.64. So that wasn't such a strange answer, Harpreet. So I don't know whether you're going to get comfortable using the BA2 Plus, or you're just going to use Excel to find the days between dates. But either way, you should get the same answer either way.
Mr. Brown, can you please do it on the BA plus?
Sure,
Because
sure. Let me just make a note of what I was looking at there. 10.0823 and 8.0424. Okay, so let me stop sharing this. Shrink this, find the calculator. So you can see the calculator now?
yes,
Okay, so I'll go second and date, and the 10th month. So 10.08 for the 8th day, and 2023, we can only put in the 23. So it looks pretty cryptic here. When we hit enter, it looks a little better. 10th month, 8th day, and the year 2023. That's DT1. Then hit the down arrow, and it has whatever was the last thing you put in it, but you can ignore that. We want the 8th month dot, the 4th day, so 04, but now we're going for the year 2024, but we can only put in the 24. Go enter. So there we can see the 8th month, the 4th day of 2024. Hit the down arrow again. And of course, it still has the 152, but we go compute. And it calculates DBD, which is days between dates.
Okay, I got it.
Okay.
Thank you.
With the days between dates, you can put in different information and solve for different things. What I mean is we've put in the DT1, DT2, and days between dates, but if we'd been given the days between dates, and we wanted to find a date 301 days either before a date or after a date, we could plug it in and it would solve it for us. You just have to have 2 out of the 3 and it'll solve for the third one. So we finished that one. Let's save that. And I lost questions. Now they begin to get fairly tricky with their moving money back and forth through time. It says loan payments of $1,725 due today, $510 due in 75 days, and $655 due in 323 days are to be combined into a single payment to be made 115 days from now. What is that single payment if money is worth 8.5% per annum and the focal date is 115 days from now? So this thing they're calling the focal date, whenever you're moving money or whenever you're trying to compare different sums of money at different points in time, because money changes value when it moves through time, you always have to move all the money to the same date so you can compare it. And the date that you move it all to is referred to as the focal date in these questions. So what we're going to do is we're going to produce a little diagram here that I call a timeline. So, and we're looking at the farthest we have to go back is today, because these are all going into the future. So we can start here with today. And we can see we had to pay, or someone had to pay $1,725. Now, they're going to have to pay another $510 in 75 days. And another $655 in 323 days. But they've said they're going to pay everything off at 115 days. And they've said 115 days is the focal date. So what we're going to have to do is this has to move forward to the focal date. This has to move forward to the focal date. This has to move back to the focal date. And once we've moved them, then we can add them all together and see what payment would pay that off. So we have two formulas here, basically. S equals P 1 plus RT for moving money forward. And then we have P equals S over 1 plus RT for moving money backward. So that's all they're getting you to do here is move this money backward and forward in time. And when it's moving forward, it's going to gain interest. And when it moves backwards, it's going to lose interest. So let's start with the 1725, 1 plus 8.5% times how many days is this going to have to go? 115 days over 365. So that's the first one we have to move forward. So if you've managed to figure out what that will become in 115 days, let me know in the chat box. 115 divided by 365 times 8.5% plus 1 times 1725. So this is going to become 1771.20. So we have to move the 510 forward. 1 plus 8.5%. Oh, not over anything. Don't know what that was. Times. Now, it doesn't have to go 115 days. It's got to go 115 minus 75 days over 365. So let's figure out what that becomes. 115 minus 75 divided by 365 times 8.5%, then plus 1 times 510, and I'm getting 514.75. This 655 has to go backwards. So it's going to lose interest. So we've got 655 over 1 plus 8.5% times, and we don't know how many days it's going to go back. It's going to be 323 minus 115 over 365. And let's see what that would be. So 323 minus 115. So it's moving back 208 days divided by 365 times 8.5% plus 1, and then 1 over x times 655. So it loses interest and becomes 624.75 1.74. So because they're paying this early, they get to pay a little bit less interest on it. And these other two, they're paying them late. So they had to pay extra interest on them. But if they're going to pay one amount, now we have to see what that one amount would be. 1771.20 plus 514.75 plus 624.74. So, yeah, that's the same answer I'm getting. 2910.69. So if they paid one bill, that's what they'd have to pay. So any questions before I save that screen and try the next one? So the next thing they've done to us some reason. So let's see what they've done here. Scheduled payments of $1,010 due 5 months ago and $1,280 due today are to be repaid by a payment of $615 in 4 months and the balance in 7 months. If money is worth 7.75% per annum and the focal date is 7 months, for some reason we've lost the end of this sentence. What is the amount of the final payment? Oh, there it is. Okay. So again, I'll draw some kind of a strange timeline to depict what's going on here. I find it easier to visualize what they're trying to tell you if you draw this little picture of it. So this was due 5 months ago. So we've basically got to start at -5, and we were supposed to pay 1010. Now it's today we're supposed to pay 1,280. So let's put today here. 1,280. And we're going to make a payment in 4 months. So we'll put 4 months here. And we're going to make a payment of $615. So we have to remember that this is a payment, not a debt. And we're going to pay the whole thing off here. We're going to pay the balance. And interest is 7.75%. So what we're going to have to do is We're gonna have to figure out what we're gonna use as our focal date. Oh, they've told us the focal date is in 7 months. So that's easy. We know this is our focal date. So as we know, this is the focal date. This is gonna have to go forward to the focal date. This one will also have to go forward to the focal date. And then we've got to add those two together because that's the amount of money we owe. Then this has to go forward to the focal date. But we can take it away, and what's left over should be the amount that we're owing there. So let's see if we can do that. 1010, 1 plus 7.75% times, and this is 5 months, so 5, but it's got to go all the way to 7 months, so plus 7 over 12. So this thing is going to go ahead 1 year. Let's figure out what that is. 5 plus 7 divided by 12, not very exciting, times 7.75% plus 1 times 1010. So by the time this arrives at the focal date, it's 1088.28. So let's do the same for the 1,280. 1280, 1 plus 7.75%. And this has to go 7/12 of a year. So 7 divided by 12 times 7.75% plus 1 times 1280. So this has gained interest. It's now $1,337.87. So that was the amount of money we owed. So we can add those two together. So we owe a total of 2426.15 in terms of the focal date, but we haven't accounted for this 615. So we've got to take the 615 forward, 1 plus 7.75%, and it's got to go 7 minus 4 over 12. So I'll take a big chance there. 7 minus 4, 3 divided by 12 times 7.75% equals that, plus 1 times 615. So in terms of the focal date, this is 626.92. And this is an amount we're paying, so we can subtract this at this point. So on the focal date, we should have to pay 1799.23. So any questions on what happened there? just keep that concept in mind that everything has to go to the focal date. Because you can't compare sums of money. Why we subtracted 7 minus 4. This 615 wasn't due to be paid until 4 months. So we only had to go from 4 another 3 months ahead when we're sort of moving it through time to the focal date. Does that make sense? It didn't have to go 7 months. It just had to go an extra 3 months. So let's take a look. They got excited and gave us some other questions here. So a loan of 3,320 is to be repaid by 3 equal payments due in 92 days, 235 days, and 326 days. Determine the amount of the equal payments at 8.75% per annum with a focal date of today. So again, we can start by drawing a little diagram to get a visual idea of what we're trying to do here. And the focal date is today. So we can put today over here. And we're making a payment in 92 days, a payment in 235 days, and a payment in 326 days. The problem is they haven't told us what the payments are, but they have told us that they're equal. So we know that these 3 X's are the same value. And they've also told us that today is the focal date. And so what we know is that this amount has to move back. This amount has to move back. And this amount has to move back. And it's a bit weird, but although we don't know what these are equal to, we know the formula that we're going to use to move them back. So we owe this 3320 here, 3320. And what we know is it's going to be equal to, so 3320 is going to be equal to X over 1 plus 8.75% times 92 over 365 plus X over 1 plus 8.75% times 235 over 365 plus X over 1 plus 8.75 times 326 over 365. And what they're expecting you to do is to factor out this x out of this term. So this thing actually becomes 3320 equals x outside of, and we're going to replace the x with 1 over 1 plus 8.75% times 92 over 365 plus 1 over 1 plus 8.75 times 235 over 365 plus 1 over 1 plus 8.75 times 326 over 365. So you get this ridiculous equation here. And then the next step they're going to get you to do is to divide through. So you get 3320 divided by everything in this bracket equals x. So I'll try to do that on the next page. I just got to make some notes of the numbers that I'm using here. So 92, 235, and 326, and it's 8.75 and 3320. That didn't work. So let's move on to the next page and see the next step here. Once we divide through, we end up with this ridiculous equation. X equals 3320 over this incredible thing. 1 plus 8.75% times 92 over 365 plus 1 over 1 plus 8.75% times 235, is it 235? Yeah, over 365 plus 1 over 1 plus 8.75% times 326 over 365. Now, what I do is I solve these sums down here and I store them. So I'll start down here, 92 divided by 365 times 8.75% plus 1. And so I get 1 over something, but I want to flip it into the numerator. So I'll go 1 over x. And I'll store that in register 1. So let me put what I'm storing in register 1. I'm going to put this STO1, but what I'm actually storing in there is 0.978421123. So hopefully you'll get the same answer there. Now I do the same here. 235 divided by 365 times 8.75% plus 1. and then hit the 1 over X, and I'll store that in register 2. So store 2, and I'm storing 0.946668828. And I'll do the same thing for the other one. 326 divided by 365 times 8.75% plus, oops, that didn't work. Got to do that again. 326 divided by 365 times 8.75% equals plus 1, hit 1 over X, and I'll store that in register 3. So STO3, and I'm 0.927514.135. So now that I have these things all stored, I can go recall 1 plus recall 2 plus recall 3 and see what that equals. So recall 1 plus recall 2 plus recall 3, I'm getting 2.8526 04086. I can hit the 1 over X. So go 1 over X and then times 3320. And I'm getting 1163.85, which is good because a whole bunch of people got there before me and you all got the right answer. So it looks fairly complicated because of that massive equation that you have to factor out, but that's the process of what they're expecting you to do there. Let's practice one more of those before we change horses totally. So let's look at the last one they've given us. A very annoying question. So on March 1st, Bear Mountain Tours borrowed $1,500. 3 equal payments are required on April 3rd, June 20th, and August 10th, as well as a final payment of $400 on September 30th of the same year. If the focal date is September 30th, what is the amount of the 3 equal payments at 6.75% per annum? So let's start by drawing a number line to try and visualize what we're being asked here. March 1st, and we don't go back any further than that. So that can be here. Let's see. April 30th. So we'll make April here. June 20th. and August 10th and September 30th. So we know they borrowed 1,500 here. And they made a payment on September 30th of 400. But they made a payment here, a payment here, and a payment here. And we're being told the focal date is September 30th. So there's our focal date. So what we've got to do is we've got to take the 1,500 forward. Then we have to subtract the 400 from it. The 400 is already on the focal date, so it doesn't move forward or backward. But then we have to move this money forward, this money forward, and this money forward, and solve for these x's, which are all the same value. So our first task is to figure out how many days from March 1st to September 30th. So you can either do that on your calculator or you can do it in Excel. But we need to know because we've got to go 1,500, 1 plus, what was it? 6.75% times a certain number of days over 365. So I'm going to wait until a few people can agree in the chat box how many days from March 1st. Now, you may be wondering what year it is, and it doesn't matter what year you use. So let's use 2021. The reason it doesn't matter is because we're not worried about leap year because there's no February 29th in here. So I've got one person that's told me how many days it is. We just need a few to agree before we commit ourselves on it. So far, I've got 213 days, 60 days, and 218 days. That's wearisome. I'm going to go with 213. I'm going to go with this being 213 days. Once we think it's 213 days, unless someone can convince me that it's not, we'll go 213 divided by 365 times 6.75% plus 1, and then times 15000. Ooh, get rid of 10. So this debt, if they just waited till September 30th, it would have become 1,559.09. Now, they paid 400 on the focal date, so we can subtract the 400. So what they actually owe is 1.59.09. And so now we know that that's the sort of the final result we're looking for, 1159.09. And these amounts of money, they're all moving forward, not backwards. So this is X times 1 plus 6.75% times a certain number of days over 365 plus X times 1 plus 6.75%, but we don't know the days yet. 365 plus X outside of 1 plus 6.75% times something over 365. When calculating days on calculator, I got error 6. Let's go to the calculator and see if we can see why that happened. Let's make a note of the dates we're looking at. March 1st, April 30th, June 20th, August 10th, and September 30th. Okay, so let's find the calculator now. Can we see the calculator? Okay, so let's start with the first we'll clear it. Let's go second date and March 1st. So March 1st is the third month and it's the first day. So 01, and I'll use 2021, 21, enter down. And the second date we're looking at is September. So September is the 9th. Yeah, the 9th month. Let me know if I get these months wrong. 9th month. And it's the 30th day. And it's still 2021. So enter and down. And we go compute. And there's our 213 days. So Balwinder, when can you figure out? Oh, you entered first date then month. Yeah, no, it's got to be month then date, because I was going to say we'd have to figure out what you did differently. While we've got the calculator here, let's figure out all the days. We've got to go from the next one we've got to do. Let's clear that and go second date, April. So April is the 4th month dot April 30th. So 30, 21, enter down. And we've already got the September date in here, which is good. We can just go enter down and compute. So we need to know that it's 153 days for part of our calculation. Clear that. June 30th. So second date, June is the 6th month dot 20th, 20, the year 21, enter, down. It's still got our second date in here. So enter, down, and compute. And you're right, it's 102 days. And now we can do the August 10th. So clear that. Second date, August, is the 8th month, dot 10, 21, enter, down. Still got September 30th in here, so enter, down, compute, and 51 days. So these are the dates we're going to need. So we'll go get rid of that. Go back to the whiteboard. The dates we've just figured out are what we need in here. So let's put them in. 153, 102, and 51. So what we have to do is we have to factor out the X again. So it's going to become 1159.09 equals X outside of all of these things, because when we replace X with 1, it's going to basically disappear. So we may as well, rather than writing them all out, at this point, we might as well store them. So let's do these calculations now. 153 divided by 365 times 6.75% plus 1. That didn't work for some reason. 153 divided by 365 times 6.75% equals plus 1. And I'll store that in register 1. But what I'm getting is 1.028294521. And then 102 divided by 365 times 6.75% plus 1. And I'll store that in register 2. But what I got was 1.01886 3014. So 51 divided by 365 times 6.75% plus 1, and I'll store that in register 3. But what I got is 1.009431 507. So now I can go recall 1 plus recall 2 plus recall 3. And what I end up solving here is X equals 1159.09 divided by 3.05 65 89041. And so let's find out what we get. Hit 1 over x times 1159.09. And I see people got there before me because that answer is already sitting in the chat box. 379.21. So, yeah, they went out of their way to make that final question as painful as possible with all the dates we have to figure out. But that's what they're expecting us to do there. So now we're going to change horses completely. Let's switch over and look at chapter 15. As scary as that sounds. What I'm going to do is I will find the Excel sheets that I've sent you, and we'll try to make sense out of those. So before we actually start doing this, let's talk about the idea of bonds. What a bond is where a company borrows money from individual people. And what the company promises to do is to pay interest on the bond periodically. And at the end of a certain time period, they pay back the money that you paid for the bond. So you get the value of the bond back eventually, but along the way, they pay you interest for the privilege of using your money while they've got it. So that's what a bond is, right? As I've put here, a bond is a financial instrument where you're paid interest on the bond at regular intervals, and the interest payments are referred to as coupons. And then at maturity, you get the face value of the bond back. So the purchase price of the bond is the present value of the face value plus the present value of the income stream created by the bonds. So when we're trying to find out how much someone is going to pay for a bond, we basically have to do two calculations. Figure out, well, what is the bond worth? And then what is that stream of payments, the coupon payments worth? So let's take a look at how this works. We've got a $1,500 2.5% bond. It's purchased 6 years and 6 months before maturity to yield 3% semi-annually. So notice we've got two interest rates here. The bond itself, when the bond was first created, the interest rate was 2.5%. Since then, the interest rate has gone up to 3%. So this means that the amount someone is willing to pay for the bond is actually going to go down, because they could go out into the market today and find investments worth 3%. So if the interest rate goes up since this bond was created, the value of the bond, in fact, goes down. And the opposite happens. If the interest rate goes down, then the value of a bond goes up. And we'll see how this works when we discuss what we refer to the premium and the discount. So we can see that this bond is a simple annuity. The compounding is semi-annual and the payments are semi-annual. We can also determine that it's an ordinary annuity. It doesn't tell us in here, but we're supposed to know, or at least the textbook tells us, that payments, that is the coupon payments, are at the end of the interest payment period. So this is an ordinary annuity. So we're going to always assume that bonds will be ordinary annuities unless we're told for some reason that the payment is at the beginning, which, as far as I can tell, never happens. So the first thing we have to calculate is the value of the coupon. So the bond rate, B, which is 2.5% semi-annual, and then we multiply the coupon, which is 1,500, by the rate, and we find out that the semi-annual coupon is $187.50. That is, for the life of this bond, every 6 months, you would get $187.50, and that's the interest the corporation is paying you for the privilege of using your money.
Excuse
So-
me, sir.
Yes?
Could you share your screen?
Oh, can you not see the Excel screen?
Yes, sir.
You can't see it. Okay, wonder why not. That's weird. See if we can figure out what happened there. Can you see my Excel screen now?
Yes, sir.
Yes, sir.
Okay, I wonder what happened there. Let me know if it goes away again. So here's we calculated that the coupon was worth $187.50. And now we can figure out the value of the bond. That is what someone's going to pay for it today. First off, we want to find the present value of the final amount. In this case, the future value is the full value of the bond. So if we're using n equals 13 because we were dealing with 6 years and 6 months. So 6 years would be 12 coupons, and another 6 months would be 13 coupons. So that's where the n equals 13. And we're dealing with the market interest rate of 3%. So if we calculated the present value of that 1,500, we find that it's worth $12,360. So that's the present value of the bond. And now we want to find the present value of the coupons. The payment here is the coupon, the $187.50. I should have put that in here, but that's what it is. And this is our formula for finding the discounted value of this ordinary simple annuity. the income stream. So we find the stream of payments today is worth 2,199. And so if we added these two together, someone would pay $14,560.07 for this piece of paper. And notice it's slightly less than the 15,000. The reason it's less is because the interest rate has gone up. So this investment that is based on 2.5% is not worth quite as much as it would be because the interest rate has gone up since this bond was created. And we could have done all these calculations on the BA2 plus. And we could have done these calculations on Excel. And we would have come up with the same answer in both cases. But just keep in mind what it is you're doing. You're finding the present value of the face value of the bond, and then you're finding the present value of the stream of income. And you can determine what somebody would pay for that bond today. So any questions that you can think of asking at that point? Okay, let's see what other terrible things they can do to us here.
So could you do in on a BA second class?
Could we do this calculation on the BA2 plus? Yes,
Yes.
let's find that. Stop sharing that. Go find that calculator. So can you see the BA2 plus now?
Yes, sir.
Okay, I'll clear it. Now, the first thing we have to do is make sure that BGN is not up, but we can see that it's not up. So that's okay. And then we are doing this. It's a simple annuity. So second PY2, enter, and if I go clear now, it'll automatically put 2 into the compounding, which is what we want. And we figured out the number 13 for N. So I have to go 13 into N. The market interest rate is 3. So 3 into IY. We don't know the present value. That's what we're looking for, so we can ignore it. But the payment we're receiving is 187.50, and we're getting this money, so it's positive. So put that into payment. And eventually we get the full value of the bond. So 15000. And that goes into the future value. And that's also positive because we're getting that money. And then we can go compute the present value. And here's this 14560.07, which is what we figured we would get with either of the other two calculations. It's negative, of course, because that's what we're paying for the bond. Did that help?
Yes, sir.
Okay. Yeah, notice we put both the payment, and we can do both calculations. When we were doing it by hand, we had to do one calculation for the future value of the bond, right? and one calculation, or the present value of the bond, and one calculation for the present value of the coupons. On the calculator, we can put them both in there. We only have to do one calculation. And same with Excel. Notice we only have to do one calculation. We can put the payment and the future value in there. Whereas when we're doing it by hand, we have to calculate the present value of the bond and the present value of the coupon. We have to do them separately. We don't have a formula for doing them together. Let's see what else they can do to us here. So a 25-year bond issue of $5 million bearing interest at 4.25%. So that's the bond rate, payable annually, is sold to yield 4.5%, compounded semi-annually. So we can see that this is a general annuity because the compounding is semi-annual, but the coupon payments are annual. We can also see that the interest rate has gone up. So this bond will be selling at a discount because it was written at a lower interest rate than the interest rate available in the market today. So, but we still have to find the purchase price of the bond. Because it's a general annuity, if we're doing it by hand, we have to calculate the value of P. So we come up with this value, and I'll always store this in register 3. So when we do it by hand, it's roughly the same formula, but we're using the value of P, and we have to do one calculation to find the present value of the bond, and a second calculation, also using the value of P, to find the present value of the coupons. And somewhere up here, we must have calculated the coupon. Oh yeah, right here. The coupon on this $5 million bond is $212,000, 212,500. So that's quite a nice coupon. So, and the present value of those coupons is this incredible number. And we can add them together to get the purchase price of the bond, $4,778,000. Notice it's not $5 million because the interest rate has gone up. So the value of this coupon goes down as the interest rate goes up. So we could do this on the BA2 plus. The nice part about the BA2 plus is we don't need to know the value of P. We still need to know the coupon, and we still need to know a value for N, which is, in this case, as it's an annual coupon, it's 25. So we have to set PY and CY separate because the payment periods and the compounding periods were different. N is 25. The interest rate is 4.5%. This is the market interest rate. It's not P. we can put in the payment, which is the coupon, the future value of the bond, which is 5 million. And we come up with exactly the same answer. But we only had to do one calculation and we didn't have to find P. So this is easier on the BA2 plus. And when we do it on Excel, we still have to find the value of the coupon. We still have to find N, but we have to find P again. So as we already found it, I've just replaced it here. But here, this rate, this has to be P, not just I. And we put the payment in, the future value in, the type, because it's an ordinary annuity. And amazingly enough, we come up with exactly the same answer. So if it's a general annuity, it's definitely easier to do it on the BA2 plus because you skip that step of having to find P. Let's take a look at another one, unless you have any particular questions there. Okay. Okay, a $25,000 10% bond redeemable at par. That means it's just redeemable for the 25,000. On December 1st, 2030, was purchased on September 25th, 2019 to yield 7.6%. So we can see the interest rate has gone down. When this bond was written, the interest rate was 10%. But now the interest rate has gone down to 7.6%. So this is a more valuable investment than anything you can buy in the market today. Because if you invest your money today, it's worth 7.6%. To be able to buy an investment worth 10%, you're going to pay a premium. So in this case, this bond will sell at a premium. And the bond interest is payable semi-annually, and it's compounded semi-annually. So we know it's a simple annuity. And of course, it's an ordinary annuity. But we have the problem with the dates. Now, although we just learned how to calculate days between dates, that isn't going to help us here. We're going to do something called COUP-NUM, which is coupon number, and COUP days BS. BS doesn't stand for bullshit. It stands for before settlement. And COUP day S, the S here stands for between coupon dates. So we're always going to look at these three calculations. And because we're always going to look at these three calculations, I've put them over here for you in this table. So when you're using this table, just fill in the dates in this green box. Don't touch anything else. Just fill them in here. And we'll come back here in a minute and we'll use it. So in this case, we were told that the date that this bond matures on is December 1st, 2030. But the date it was purchased on, which is what they call the settlement date, is September 25th, 2019. And so let's take those dates over to this coupon dates thing and plug those in. Just put the date in here. December 1st, comma, space 2030. And September 25th, comma, 2019. Now we've got two other things here. The frequency, that's the fact that they're compounded semi-annually. This will almost always be 2. Once in a while, they throw in one that's compounded quarterly, and you'll have to change this to 4. But 99% of the time, it's 2, which is semi-annual. And this thing here, called the basis, put in a 1. There are other countries that use a different basis here, but your textbook and Canada leave it at 1 all the time. So for some reason, this didn't work at all. What did I type in wrong? 9/25 2/19. September 19. That's weird. Why didn't that work? 25 September 19. Oh, I've put, notice what I did wrong here. I put the maturity date in this box, whereas they're expecting the maturity date in this box. So let's try it again. December 30th, comma, 2030, and September 25th, comma, 2019. So now that I've got these in the right order, notice what it's told us. There are 23 coupons left on this bond. In other words, there's 23 times that coupon is payable. But this, because we're looking at between the coupon dates, we need to know that when the coupon was sold, the person owning the coupon or owning the bond held it for 87 days out of a total of 183 days. The half a year. And when these people buy and sell these bonds, they don't want to give away even 1 day's interest. They want to make sure they get paid interest for every day that they're owed interest for. So they're going to have to know that the person who had the bond had it for 87 out of 183 days. So they're going to have to be compensated for those 87 days. So when I come back here, I can see that for some unknown reason, this is a different answer. Let's figure out why. That works. That works. $187. So I'm not sure why that 180 or why that is not 116. But I'm going to go with the 116 here, and I'll figure out why that didn't work later. So we know the value of the bond is 1,250, and you're going to have to struggle with these coup num, coup day, and coup days. And then if we're calculating this thing by hand, it's now an even more complicated process. Notice we first off have to find the present value of the bond, which we had done. Then we're going to find the present value of the coupon stream. And this is all the coupons that are left on the bond. We still haven't dealt with the fact that that they've got to divide up this one coupon between the buyer and the seller. So what we do is when we add these two together, we find the price of the bond on the last coupon date before the bond was sold. So we know what this coupon, or what the bond would be worth if it was sold on the coupon date, but now we have to worry about the fraction of the coupon before the actual settlement date. Oops, that didn't work. I'm just trying to spell settlement correctly. So the fraction of the time we're looking at is 116 days out of 183. So what we're going to do is we're going to find the present value of just that fraction. And so we're going to take the present value that we figured out up here that the bond was worth, and we're going to take that forward for 116 out of 183 days and find out that once we add that fraction of the time of the bond, then this bond actually becomes worth 30,253.48. And then they do this other calculation called the accrued interest to get what would be called the quoted price on the bond. Because what they call the quoted price is based on the fraction of the coupon for that amount of time. So if we just took the coupon itself, multiplied it by that fraction that we created, we'd get this 792.35. So although we have a cash price of the bond, which is what someone would actually pay for it, just to make it totally confusing, they have this thing called the quoted price of the bond, which is what the bond would be quoted at, which is only this 29,461. So annoyingly enough, although you can calculate the cash price, you still have to remember that if they ask you for the quoted price, it's not quite the same thing. Now we can do this calculation on the BA2 plus. This is what we would have done with the coupon and the future value of the bond. And then we'd still have to use the Coop BS and Coop S to find the fraction of the days. And notice we've put that in fraction in here. We've just typed it right in, equals 116 over 183. And it takes this forward and gets this 30,000, which is again, this cash price that we were looking for. It doesn't give us that quoted price. It gives us the cash price. And we'd still have to do this nonsense with the accrued interest to find the quoted price. Now we're going to take a look at something totally different. This incredibly confusing piece of nonsense that I've put here is using the bond program on your BA2 plus. So if you look at the BA2 plus, and we'll go over and look at it in a minute, but if you look at the BA2 plus, what you'll see is the bond is the second function of the 9 key. So if you see the number 9 key on your calculator, notice the little word written above it is called bond, because they know that you're going to want to do this calculation. So let's go over to the BA2 plus, and I'll do this calculation and I'll try to explain what's happening when we do it. So, can you see the calculator?
Yes.
Yes. I'm hoping we can see the calculator. And so I'll clear everything. And I'm going to go second and down here to the 9 key bond. So the first thing we do is we see STD. No, that's something else. SDT. And this is the settlement date. So we're going to have to put in the 9th month, just the same format as we're using. 9 dot. So it's the 9th month, the 25th day of 2019. So enter. So we can see the 9th month, the 25th day, 2019. So we've put the settlement date in, go enter and hit the down arrow. Now the coupon. And how many coupons? What do we need here for coupon? I've put 10. I'm not sure if that makes any sense. Let's put 10 in. For some reason, I don't think that 10 makes sense, but let's put it in anyway. 10, enter, down. And now the RTD stands for redemption date. That's the maturity date. They call it the redemption date. And so what do we know? It was the 12th month, the first day of the year 2030. So enter, and we can see 12/01/30 down. Now, RV doesn't stand for a recreational vehicle. What they're going to do is they're going to give us the value of a $100 bond. It's always going to be 100. We then have to multiply by whatever it takes to deal with the bond that we actually have. But they don't put in a value of a bond here. They do them all as $100. So we can just go enter and down. Now act, it's the same thing as the basis that we had in the other one, but we can leave this totally blank. It doesn't matter to us, but just don't change it to anything. 2 times a year is the fact that this is a semi-annual bond. In really, really rare cases, you might have to change it to 4 times a year, but 99% of the time it's going to be 2 times a year. So go enter or just go down because it's already there. And the yield, oh, okay. This coupon up here that didn't make any sense to me again. This was the interest rate on the coupon. And so it's correct. The interest rate on the coupon was 10%. And now the yield is the market interest rate is 7.6. Enter and down. And the price, we're going to go compute and we get a price. Notice this price doesn't really make a whole lot of sense to us, but we're going to store it anyway. Go store 7 because we're going to need that number. And notice we have down here called accrued interest. We had to do that separate calculation on the BA2 plus or by hand to get the accrued interest. But if we go enter here and down, we get this accrued interest and we need that number too. So I'm going to go store 8. And now we've got those numbers. This is just explaining what all of this we just did was. So let's keep those numbers in mind. And the number we got for price and AI are based on a $100 bond. So let's go back to our screen here. There's a message here in chat, what someone had to say there. Okay, so you can see the Excel spreadsheet again.
Yes, sir.
Okay. Notice what I'm going to do now is because we have a $25,000 bond, I've got to multiply the numbers they gave us by 250. Because if I take 25,000, divide it by 100, I get 250. So what I'm going to do is I'm going to go recall 7 times 250 and I get this number. And then recall 8 times 250 and I get this number. And if I add them together, I get this 30,235.47. And if we go back up to all these other calculations we did, notice we're only 1 penny different here. 30,235.48 on the BA2 plus. And when we did it by hand, we also got the 30,235.48. So this number here that we're getting of 30235.47 is actually, I say, don't worry about the 1 penny. It's actually a more correct answer than we got by calculating it by hand. So, but on Moodle would accept either answer. And remember, this is our cash price. This isn't doing this calculation for the what they call the quoted price. I wouldn't worry about that quoted price right now. Just worry about making sure you can get the cash price. And so if you're doing it on the BA2 Plus, they have this pre-programmed package that'll allow you to do that. And you just have to remember what all these things mean and follow this procedure. And it gives you both calculations show up here, and then you have to combine them to get the cash price. Now, we could do this whole thing on Excel. We still have to find the value of the coupon, still have to find the number of coupons left. And we have to find the decimal value for the market interest rate. And if we plug in both the payment and the future value, we come up with this value. Then we have the problem of that accrued interest. So we're going to find the future value. We're going to start with the answer we got up here for the present value, and we're going to take it forward this fraction, the 116 over 183 at this rate, and notice we come up with this cash price. We could still find this quoted price, but we're not too worried about it. And now we're going to look at something again, which is totally alien. But the point is, people out there in the financial world do these calculations all the time. And they don't want to do them by hand because nobody in their right mind wants to do them by hand. So they've programmed both the calculator and written functions in Excel to come up with the correct answers. So someone has asked how many decimal places to be set for this chapter. I would set it to 2 decimals. You could try it one way and the other way, but I think it would be better set to 2 decimals. Here, if we do this thing in Excel, we put in the settlement date. Notice, where are we calculating this? Down here, it's the price. The function we're using here is called price, and it has all of these arguments that we're looking at: the settlement date, the maturity date, the bond rate, the market rate. Again, we're going to use a redemption value per 100. The compounding frequency is 1, and the basis is 1. All of these arguments, and we come up with this same number, 117.84. We multiply it by 250, and we get this 29461. But amazingly enough, this calculation gives us the quoted price. This doesn't give us the cash price, and it doesn't give us the accrued interest. So it's a bit weird that the Excel price function gives you that thing they refer to as the quoted price, whereas the the function that's programmed into your BA2 Plus calculator gives you the cash price. So you have to make sure you are aware of what the question is asking. But usually the question is asking for the cash price. Probably because that's the important number. That's what someone is going to pay. So let's see what other annoying things they can do to us in this section. Get rid of that split screen. So a $1,000 5% bond with semi-annual coupons redeemable at par on September 1st, 2023 is bought on March 1st, 2020 to yield 4%. So the first thing we see is that the market price or the market interest rate has gone down. So this bond will sell at a premium. We also see that it's a simple annuity. So they want us to compute the premium or discount and the purchase price. So we can calculate the value of the coupon using the bond interest rate. It's a $25 coupon. And we need to use Coop Num, Coop Days, and Coop BS. So once we plug these dates in, we find that there's 7 coupons left. And because this is 0 out of 184, we can see that this thing is sold exactly on the coupon date. So we don't need to worry about any fraction of days between coupon dates because they were nice and this thing was sold right on the coupon date. So what they've done here is they've calculated the value of the coupon based on the market interest rate. Up here, we calculated the value of the coupon based on the bond interest rate. So the actual coupon is worth $25. But if we were calculating it based at the new interest rate, it's only worth $20. And so then we're going to find the yield is 25 minus 20 is 5. So this bond or this coupon is worth more because the interest rate has gone down. And so then we're going to calculate the present value of this difference. Rather than calculating the two present values and taking one away from the other, they just go 25 minus 20 equals 5, and they just calculate the present value of this income stream because this coupon is worth $5 more than any coupon you could buy in the market today. So I've tried to explain that. If the market interest rate is lower than the bond interest rate, the yield will be positive and the bond will sell at a premium. An investment paying 5% is worth more than any investment available now that only pays 4%. If we go in the other direction, it says, if the market interest rate is higher than the bond interest rate, the yield will be negative and the bond will sell at a discount. And in an investment paying 5% is worth less than any investment available now that pays 6%. So as interest rates go up, the value of your bond goes down, or vice versa. So they calculated something they refer to as the book value of the bond. The 32.36 is the premium. The bond is worth $1,000. So this bond is what they call the book value of the bond is 1,032.36. And then they create these annoying schedules. And I'm not really sure how much you'll have to worry about it, but this is how they've set it up. The number of coupons, what the coupon is worth, the interest on the book value, which was what we calculated up here, and the premium as this gets closer and closer to the final date, and the remaining premium, which ends up being absolutely nothing. So we could do this whole calculation on the BA2 plus. Again, dealing with the fact that we're only worried about the present value of this $5. So the payment is the $5. The number of coupons is 7. The interest rate here is the market interest rate. And we come up with this 32.36 again. And we could do this whole thing on the BA2 plus, the pre-programmed bond function. The settlement date, we'd have to put in. The CPN stands for the rate on the bond. RDT stands for the redemption date, the maturity date. The RV is still 100. Ignore ACT and 2/Y. Just hit the down arrow. The yield is the market interest rate as opposed to the bond interest rate. And then you go compute the price. And notice here it comes up with 103, blah, blah, blah. But remember, we're using a basis of 100. We'd have to multiply this, in this case, by 10 to get our answer. And we do. I stored this in 7, and I did recall 7 times 10, and there's that 1,032.36. And there's no accrued interest, so we're not worried about it. And I didn't bother doing it on Excel because Excel doesn't give us the answer we want here. Excel gives us the quoted price, but we want the actual cash price of the bond. So I urge you to get used to doing this. Try it a few times on the BA2 plus. Let's see what other nonsense they can inflict on us. So a $5,000 bond with 8% interest, payable semi-annually, redeemable at par, on June 1st, 2031, was bought on December 1st, 2017, to yield 9%. So the market interest rate has gone up. So this bond will be selling at a discount, compounded semi-annually. The bond was sold on September 22nd. So we're not worried about when the bond was first bought. we're worried about the September 22nd date. And notice they've told us this weird number here at 101.375. So we have to figure out how to deal with this weird number, determine the gain or loss on the sale without constructing a bond schedule. So we can see the bond is, or the coupon is worth $200, but at the market interest rate, the coupon would be worth $225. So we're going to have to keep those two numbers in the back of our mind. And then we've used Coup Num, Coup Day BS, and Coup Days. And we found out that there's actually 20 coupons left on the bond. But we're in between coupon dates. So 113 and 183. So that's what I've said here. We can see that when the bond was sold, there are 20 coupons left. And we can see that the seller held the bond for 113 days out of a total of 183 days. So the seller, or the purchase price, should compensate the seller for these 113 days because he doesn't want to lose even 1 day's interest. So when we do 200 minus 225, we get a negative 25. Notice that the yield is negative because the interest rate has gone up since the bond was issued. We find the present value of this income stream, and it works out to be negative because this number is negative. And so it's a discount, not a premium. So when we calculate the book value of the bond, we take the $5,000 minus the discount. So the book value is this 467,480. But we still have this annoying fraction to deal with. So we've got to take the book value and we've got to find the future value for 113 days out of 183. So we get this 480360. Now let's see if this thing does any different. Why did I store it as number 7? Yes, you could store it as anything. I just get used to storing it in storage register 7. So this is weird here that there's no accrued interest here. That's annoying. Let's see what happened there. I think, see this 0 here? I think I've typed the wrong number in here. So let's go over to the BA2 Plus and calculate this. Let me share my calculator. Okay. Can you see the calculator?
Yes, sir.
Okay. Let's try this whole calculation and see about this weird 0, which shouldn't be here. So we're going to go second bond, and we're now looking at September 22nd, 21, which is when this bond was purchased. So 9.2221. Enter down. The rate on this bond is 8%, I hope. Percent. Enter down. The redemption date is 6.0131. So we're hoping that's June 1st, 2031. Enter down. The sort of basis we're looking, RV is 100. So we like that. Act we can ignore. 2/Y twice a year we can ignore. The yield on the bond is now, or the yield in the market is now 9%. Enter down. And the price will have to go compute. And I'm getting 96 here, whereas I've got 103 here. So that's a big problem. We'll have to figure out what I did wrong here. Let's go store 7 and down and store 8. And then we can forget that. So 8 and 9, were those the correct interest rates? 8 and 9. December 1st, 2017. Oh no. December 22nd, 2021. Yes. For some reason, I've put this 103. No, don't know what I've put there. So let's see what happened here. So you can see my Excel spreadsheet.
Yes, sir.
So I did recall 7 times 50 because this is a $5,000 bond, and I got 4680.11. And then recall 8 times 50, I got this. And I added them together and got 4803.61. And I'm just wondering if that makes any sense whatsoever. Yes, it's the same answer we wanted. Just don't worry about the 1 penny. So I'm not sure about these numbers here. I don't know where they came from, but they shouldn't be there. So I'll have to fix that. So if you did that on your calculator, did you get the same answers?
Yes, sir.
Okay. Yeah, so I don't know what should go in here. I'll have to redo it and fill in these answers, because these ones seem to be correct. So they said, now what they're doing is comparing this answer we've got here with this number that they get from what's called the market quotation. See this 101.375? This is referred to as the market quotation. And they use that to generate a value for the bond. So the market quotation would be 5,000 times this 101.375, and that equals this. So at this market quotation, that's what they would refer to the value of the bond as, but we've figured out that the bond, oh, and then from the market quotation, they added 113 days worth of interest. So 5,000 at 4% for this amount of days gives us $123.50. So they've added that to the market quotation to get what they referred to as the proceeds. And then they compare the book value of the bond, which is what we've calculated, with what they call the proceeds of the bond. And they've determined that we've made a gain of $388.64. And so that is the fact that even though this bond was selling at a discount, we actually, because of the price we were able to buy it for, we actually made a gain on the sale. Quite a confusing concept between the market quotation and the actual amount that we bought this thing for. So the bad news is that I've used up all the time I can torture you with today. So let's take a quick look at this next question and see if we can make sense out of it. So suppose you're considering investing in a Bombardier Incorporated corporate bond with a $7,500 face value that matures in 15 years. The bond's coupon or bond rate is 7.35%. Interest is paid semi-annually, but the market prices this bond at 109.1724. So they're going to tell us we can figure out the sort of the quoted price of this bond with this. So the quoted price is the bond times 109 point blah, blah, blah %. So this is the quoted price of the bond. And then we're going to do this thing called finding the average book value. And this is a long, complicated process. And if you look on the formula sheet, I've listed this whole process. And if you're going to follow it, it's worth following it step by step. The face value of the coupon we can get, the number of coupons left on the bond, the total interest is the coupons times the number of coupons. And then, like we did on the previous question, the quoted price minus the face value gives us whether this thing is at a premium or a discount. And then we can use the total interest minus the premium divided by the number of coupons to find the average income per coupon. And then we find the approximate value. So the average income per coupon divided by the average book value, multiply it by 100, and then by the number of periods per year. And we come up with an approximate value for I. Now, that's a very painful process, but Excel gives us a yield function, which will give us a better answer. So let's take a look at the yield function. Notice down here, the function we're doing is yield, and all these arguments. So the settlement date we can put in, the maturity date, the bond rate, this price that they've given us, the redemption per 100 again, the frequency, which is going to be 2, and the basis, which is 1 again. Now, notice in the question, they just told us it was a 15-year bond, matures in 15 years. So here, I've just chosen 2 dates, 15 years apart. And then we calculate the yield. And notice, this gives us 6.3903 with what did we have to do? We had to multiply it by 100 and round it by 4. Now, this is the actual correct answer. This answer we got up here was an approximation, and I don't know why they made you go through this whole process to get an answer which is just a good guess, when if you use the yield function, you get the absolute correct answer. But the bad news is in the textbook, they want us to use this whole process, and the answer they're expecting is this approximation. So you're going to run into places where you wish you could do this, but you're going to have to do this whole process that I've put in the formula sheet. Now, you can also do this on Excel. And this looks painful because we had to put all 15 years worth of coupons twice a year. So we had to do 30 cash flows of the amount. We had to put this interest rate per compounding period. Where did we get that? Did we have to calculate P? And then down here, we have a function called net present value, NPV. So we can calculate the net present value, and we can see how this whole thing works. But you don't have to worry about all this nonsense on Excel. What you have to realize is that when they're asking for this approximation, you've got to go through this whole process, finding the approximate yield rate, even though the annoying part is you can get the exact answer by using the yield function. Okay. Well, I'm sorry I've tortured you for almost a full 3 hours, just minus 1 minute. And I hope that when you work through that material, it'll make a little more sense. I realize that seeing it all in one go like that is probably incredibly painful, and you now have a headache. But contact me during the week if you're having difficulties with figuring out how these things all work, and I'll try to make it work for you. So take care. Have a good day.
Thank you, sir. Wish you the same.
Yes, yeah, that's quite a lot of work for you today. I feel bad for you, but good luck.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Yes, don't hesitate to contact me. I know that was a lot to take in. I will post that recording on my YouTube channel once it downloads. Bye now.
Bye.